Hello everyone. Today's topic is voltage, current and input impedance of a transmission line. Let us assume a transmission line of length L, characteristic impedance Z0. For our analysis, we are assuming differential length in a transmission line. These all are the primary constants of a transmission line. Equation 1 and 2 are the voltage and current decay equation. Now let us differentiate equation 1 with respect to x and replace the derivative of current term with the current decay equation. The final expression is obtained as follows. As gamma, which is the propagation constant in a transmission line, get replaced by this constant term. We get the final differential equation as follows. On solving this differential equation, we get the expression for voltage and current, which are as follows. As we know that the impedance, which is the ratio of voltage and current, which is on resolving this, we get the solution of impedance as follows. This is the impedance of transmission line at a particular distance x from the load. Now for calculation of input impedance, replacing x is equals to L and assuming transmission line to be lossless, that is gamma is equals to j times of beta, attenuation constant tends to 0. This is the final expression for the input impedance. This must be kept in mind whenever we solve question related to the input impedance. Now analysis of input impedance is done for different length of transmission line. Case 1, when length is equals to lambda by 8, electrical length is equals to pi by 4, input impedance is obtained as follows. As electrical length is generally the product of phase constant and the length of a transmission line. Now case 2, when length is equals to lambda by 4, electrical length is equals to pi by 2, input impedance is obtained as follows. As here we get the important conclusion that input impedance is inversely proportional to the load impedance. So whatever behavior is obtained at the load, inverse is been reflected to the input side. For example, if the load is short circuited, input is open circuited. This is the most important characteristics of an quadrilateral wave transmission line. That's why it is called as impedance inverter device. Case 3, when length is equals to lambda by 2, electrical length is equals to pi, we get Zin is equals to Z0. An important conclusion can be drawn out of it, that is, half-wave transmission line transfer the load impedance to the input terminal without any change. That implies for every lambda by 2 distance travel, the characteristics of transmission line repeats itself. Thank you.